Alright, today we are doing our last lesson on transformations. Today we are going to talk about rotations. Our objective will be to identify and use rotations. Alright, our definitions for today. A rotation is a transformation in which a figure is turned about a fixed point. The fixed point is called the center of rotation. So with our other transformations, we usually picked out one key word, like translation was slide, reflection was flip, dilation was either bigger or smaller, depending on which way it went. For a rotation, our word to remember is turn or turned. Alright, for rotations, we have to worry about the direction and the degree. So first, how can we turn objects? That would either be clockwise or counterclockwise. How far to turn the object is measured in degrees. We are always going to use a multiple of 90 for our rotations to make it easier on us. So 90, 180, 270. If you need to draw yourself a little picture to remember, if we're turning clockwise, that means we're going to turn that way. Okay, the same way that the hand of a clock would move. Counterclockwise is going to go the opposite way. Oop, that looks like the same way. There we go. Counterclockwise would go the opposite direction. Note, after a rotation has been performed, the image is going to be congruent to the pre-image. So it will be the same size and shape. It will just be in a different orientation. On these examples, we are just going to have to freehand our rotation. So we have to imagine that we are going to pick up this letter T, and we are going to first rotate it 90 degrees clockwise, and then 180 degrees clockwise. So 90 degrees clockwise means that we're going to turn it one time 90 degrees. If we do that, our T is going to look like it's sideways. So imagine pulling it and turning it to the side. So here we're at 90 degrees clockwise. Technically this should be the same size and shape. It's just harder for me to do that drawing. If we go 180 degrees clockwise, we're going another 90 degrees. So we're going to take this one and turn it some more. Now it's going to look like it's upside down. So once we get down here, this is 180 degrees clockwise. I want you to try doing the same thing with the H, except this time you're going counterclockwise. Going back to the T or the H, whichever one you would prefer. We'll do the H ones on here just so they're in the video for us also. If we were to do either of these and do it another 90 degrees, so we do it 270 degrees. That's going to turn it one more time So it's going to be sideways again. You can do it on either one of these. If we were to turn it one more time after that, where would we be? 360, which would take us back to the beginning, back to on top of the original figure. Okay. Also notice that I could have gotten the same H's going clockwise. 90 degrees clockwise is the same as 270 counterclockwise. We have another note. Often rotations are done on the coordinate plane centered around the origin and in a counterclockwise direction. There are coordinate rules to use to find the new ordered pairs for the rotation. We're going to learn the rules for both clockwise and counterclockwise. It's really the same set of rules. It just depends on which direction you're going, which rule you use, and how many degrees you're moving. These rules are a little bit expanded from what is printed in the guided notes. So first of all, we added counterclockwise 270 at the bottom. Also, we added a column of what it means clockwise. So we already mentioned that a little bit, but I would include the clockwise information. So you need to add a little bit to the chart that's in the notes. You need to add a row at the bottom beneath it. You've got room to do that. You also need to make a note either in the middle of the chart or off to the side, the clockwise equivalents. These rules are what we're going to use when we're doing this in the coordinate plane. So if we start at x comma y and we are rotating counterclockwise 90 degrees or clockwise 270 degrees, those are the same thing, then we are going to switch the x and y and make the y negative. It applies for 270 clockwise and 90 counterclockwise. So if it helps, I'll break these up with lines. If you want to use shorthand, we can call counterclockwise CCW and clockwise just CW. For 180 degrees, it doesn't matter if you're going clockwise or counterclockwise, it's the same thing. You're just going to switch x and y to both be negative, but you do not flip-flop where they are. For 270 counterclockwise, that's the same as 90 degrees clockwise. We flip-flop the x and y, and we make the original x negative. In our examples, we are asked to give the new coordinates after the rotation around the origin. So we are given these coordinates 3, -2. We are rotating 90 degrees counterclockwise. So if we refer back to that table, we have x, y as our starting point. Under a 90-degree counterclockwise rotation, our new coordinates should be -y, x. So what that means for us is that our y is changing signs and moving to the front. So what number goes in here? A +2. The y changes signs and moves to the front. The x just goes to the back. It stays the same. What is it? 3. All right, for a 180-degree counterclockwise rotation, our rule is just to change the sign on both x and y. So instead of -5, comma, +4, what would we have? +5, comma, -4. And on number 5, we've got -1, -4 under a 90-degree counterclockwise rotation. So that's like example 3. The y is going to change signs and move to the front. So what does it become? A +4, and the x just stays the same and moves to the back. -1. On example 6, we are graphing the figure. We are going to rotate 90 degrees counterclockwise and give the coordinates and plot them of the new figure. We got a lot to do. First thing, we're just going to graph the original points. To get to -4, 4, I'm going to go which direction? From my origin. Left 4 and then up 4. Left 4, up 4, put a point, that's point R. Then point S is going to be at -2, 3. How do I get there? Left 2 and then up 3. That will be point S. To get to point T, -3, comma, 1. Left 3, up 1. There's point T. So that is our original figure. If I am rotating 90 degrees counterclockwise, I need to figure out what R prime, S prime, and T prime will be. For 90 degrees counterclockwise, the Y changes signs and moves to the front. So for R, what is going to be my new front coordinate? A -4. The X stays the same but moves to the back. So what goes back here? Also a -4. Let's do the same thing for S. What's going to be in the front here? The Y changes signs and moves to the front. -3. The X stays the same and moves to the back. -2. What about for point T? What's going to be in the front? -1. The Y coordinate changes signs and moves up. The X coordinate just moves to the back. Then we have to plot those points. To get to -4, -4, where do I go? Left and then down. Left 4, down 4. That's going to be my R prime. What about -3, -2? Left 3. And then down 2. So that is my S prime. And what about -1, -3? Left 1, down 3. That is my T prime. Okay, so I took this image and I turned it 90 degrees. If you're turning 90 degrees in some direction, you should expect to move quadrants. It might not be as obvious if you don't start fully in one quadrant, like if you're split over an axis, it might be a little harder to see. But if you are clearly in one quadrant and you move 90 degrees, that's going to move you into the next quadrant. If you move 180 degrees, that's going to move you over 2 quadrants. 270 degrees, that'll move you 3 quadrants. Okay. Questions about example 6 before we do 7? All right, this time we are plotting it and rotating 180 counterclockwise and then plotting our new points. To get to 1, 4, where do I move? Right 1 up 4. That gives me point A. What about 2, negative 3? Right 2 down 3. That gives me B. And what about negative 2, negative 1? Left 2, down 1. That's point C. And then we connect them as best we can. This time, obviously, we're in all the quadrants, so it's not going to be as simple as just moving it to one different quadrant. Let's find A prime, B prime, and C prime. To do this, what's our rule for 180 counterclockwise? Switch the signs. So instead of 1, 4, what do I have? Negative 1, negative 4. Instead of 2, negative 3, I have negative 2, positive 3. Instead of negative 2, negative 1, I have positive 2, positive 1. And then I have to graph all of those. How do I get to negative 1, negative 4? Left 1, down 4. So there's my A prime. What about negative 2, 3? Left 2, up 3. There's my B prime. And 2, 1. Right 2, up 1 is my C prime. And again, we connect our points to make our figure.